Hello, children. How are you? I hope you all are fine. Students, this is my second video on heat transfer. In my first video, I have explained what is heat and how is heat energy transferred from one substance to another substance. And some of the concepts on heat transfer, that is vaporization or boiling, evaporation, and their difference that I have explained in my previous video. And today I'm going to explain thermal expansion. Thermal expansion in solids, liquids, and gases. So, students, welcome. Welcome to our science channel, Sandeep and Easy Learning. Let's start. Students, most substances increase in their dimension when they are heated. Students, when a substance is heated, the molecules of that substance absorb the heat energy. And as the molecules absorb the heat energy, the kinetic energy of the molecules increases. And the molecules start moving more vigorously. As a result, the distance between the molecules increases and the substance expands. Students, as this type of expansion in substances occur due to the absorption of heat energy, that's why it is called thermal expansion. Students, different substances expand on heating in different amount when they are subjected to the same amount of temperature. Students, solids expand a little on heating. Students, in this picture, how the molecules in a solid are arranged under two conditions. When the solid is cold, then how the molecules are arranged in a solid, and when the solid is at a higher temperature, then how the molecules in the solid are arranged, that are shown in this two picture. Students, we know that in a solid, the molecules are closely packed because the intermolecular force of attraction is very strong. That's why, though the molecules vibrate at their position, but they don't move apart from one another. For this reason, the molecules are held together firmly. But when the same solid is heated for some time, then the molecules absorb the heat energy, and as a result, the kinetic energy of the molecules increases, and the molecules start moving more vigorously, and they try to move apart from one another. And for this reason, spaces appear or gaps appear in between the molecules. As a result, the solid expand. But still, solids expand a little on heating. But students, we know that in liquids, molecules are loosely packed. And there are also free space in the molecules in a liquid in comparison to solids. So on heating, the distance between the molecules increases. So liquids expand more than solids on heating. But students, we know that in gases, molecules are free to move because there is almost no force of attraction between the molecules in a gas. For this reason, gases expand the most on heating. Students, thermal expansions are of three types: linear expansion, the second type is superficial expansion, and the third type of expansion is cubical expansion. Students, the first two type of expansion, that are linear and superficial, both are related to solid only. Students, when a solid increase in length on heating, that is called linear expansion. And linear expansion of a solid depends on the three factors. that is original length of the solid, increase in temperature, and the third factor is nature of the solid. Students, if two rods of different size of a same metal are heated for the same amount of time, then the rod which is longer in size, that will expand more than the rod which is smaller in size. Students, the second factor is increase in temperature. If two rods of the same metal and having the same length are heated to different temperatures, then the rod which is heated to a higher temperature will expand more than the rod which is heated to a lower temperature. And the third factor, student, the nature of the solid. Students, if two rods of different metals having the same length are heated to the same temperature, then one rod will expand more than the other. But which rod will expand more? That depends on the nature of the metal. Students, the second type of thermal expansion is superficial expansion. Superficial expansion of a substance occur in its area. And students, area means we know what? That increase in length and breadth. So when a solid increase in area or increase or expand in length and breadth on heating, that is called superficial expansion. For example, the area of a plate or a sheet of metal increases on heating. Students, the third type of thermal expansion is cubical expansion. Students, when a substance increase or expand in volume, then it is called cubical expansion. Students, cubical expansion occur in different type of substances, solid, liquid or gas. When solid, liquid or gas on heating expand in volume, volume means in three dimension, length, breadth and height. So when a substance expand in volume on heating, that is called cubical expansion. Students, a Dutch mathematician and natural philosopher, Sir William Jacobs Gravesendis, performed his famous ring and ball experiment to demonstrate thermal expansion in solids. Students, in this experiment, an iron ball is suspended from an iron stand with a hook and by an iron chain. And when the ball is cold and having its normal size, then it can just pass through this iron ring. If the ball is heated for some time and then again it is trying to pass through the same ring, then it will be observed that the ball is not passing through the ring. Why? Because as the size of the ball increased or as the ball expanded on heating, that's why it is not passing through the ring which it was previously passed through when it was cold. So if this ball is cooled down again, then it will be again pass through the ring. So this experiment proves that solids expand on heating. But students, different substances of identical dimensions expand in different amount when they are heated through the same range of temperature. And it depends on the nature of the substance. Brass expands 1.5 times more than steel, and aluminum expands twice as much as steel. Students, in this activity, a bimetallic strip, which is made up of iron and brass, is taken, and these two strips are either welded or riveted together. If the strip is heated for some time, then it will be observed that the bimetallic strip has got a curved shape. Because brass, we know that brass expands more than iron. And as a result, the brass expanded more. So to adjust its increased size, it got curved, taking the iron strip inside, and the brass strip remained at the outer side of the curve. So this experiment shows that different substances expand by different amounts on heating. Students, this thermal expansion of substances has some advantages and disadvantages both, and it has also many useful applications in our daily life. One of its application is that the horse carts and bullock carts have wooden wheels, but these wooden wheels are fitted inside a metal rim, which is a little smaller in size than the wooden wheels. So to fit the wooden wheel inside the metal rim, first of all, the metal rim is heated for some time. And on being heated, the metal rim expand in its size. Then easily the wooden wheel can be fitted inside the metal rim. And after that, cold water is poured on the metal rim. And the metal rim cools down and it comes back to its normal size and grips the wooden wheel tightly. But the expansion in metals also have many disadvantages, or it creates sometimes hazards. And to avoid the hazards, some arrangements are necessary to be made. Students, on railway tracks, we have seen that some gaps are left in between two successive rails. Because in summer season, when the rails will increase in its size due to the heat of the sun, then the rails can accommodate this free space to readjust its increased size. Otherwise, the rails will bend outward, which may cause great accident. For this reason, the gaps are given in between the successive rails to absorb the effect of expansion in summer season. Students, same way, iron bridges are fixed at one end and the other end of a bridge rests on rollers. Because in summer season, when the bridge will expand in its size, then the rollers can move forward and adjust its increased size. And in winter season, when the bridge contract, then the rollers move backward to readjust its construction. Same way, students, the telephone and electric wires are always kept loose between two utility poles. Because in winter season, when the metal wires will contract, then they would not tear off or it prevents them from snapping in. Students, cemented floors, when they are laid, also small gaps are given in between the blocks. Because in summer season, when the metal road expand in size, the expanded size can be adjusted by using the space given between the blocks. And also in winter season, when the blocks will contract, then there appear no crack on the floor. So students, to absorb the effect of contraction in winter and expansion in summer, this type of gaps are given in between the floors. Students, we have come to know that in a bimetallic strips, the metals expand in different amount when they are heated to the same temperature. And for this reason, bimetallic strips are used as thermostats in electrical heating devices such as electric irons, geysers, toasters to control temperature. And these bimetallic strips are also used in automatic fire alarm systems. Students, in metal pipelines, loops are provided, and these loops help the pipelines to adjust its increased size in summer and also its contraction in winter. Because in the loops, the spaces that are left at the joining places of the metal pipelines. So when the pipeline will expand in size, it can adjust its increased size, and also when it will contract in winter, that time also this loops helps to adjust their contraction, and this way no damage occur to the pipeline. Students, in glassware, we have often seen some cracks appear inside the glasswares. Students, glassware or glass has a certain amount of thickness. And when we pour hot water or tea into a glass tumbler, the inner layer of the glass absorbs the heat. And we know that glass is a not a good conductor, or we can say that glass is a poor conductor of heat. So the conduction of heat through the glass is slow. So when we pour hot water or tea inside the glassware, the inner layer of the glass is hot, while the outer layer remain relatively cold than the inner layer. And this difference in temperature, the difference in temperature in the inner layer and the outer layer of the glassware causes the inner layer to expand significantly more than the outer layer. And this difference in amount of expansion builds up a strain, which causes the glass tumbler to crack. Students, in automatic fire alarm system, an automatic fire alarm is a device that detects excess heat or smoke in its vicinity. And in case of a fire, it sounds a loud alert that indicates danger. Students, in this automatic fire alarm, a bimetallic strip of iron and brass is used, and one end of the bimetallic strip is fixed to the wooden board, and the other end of the strip is kept free. And just above the other end of the bimetallic strip, a metal screw of brass is provided, and it is set just 1 millimeter above the free end of the bimetallic strip. So, in case of fire, as it is, the bimetallic strip will get heated. So, as it is a bimetallic strip, so the brass will expand more than iron. As a result, the strip will get curved or bent, and this free end of the strip will rise up and touch the screw. When the free end of the strip will touch the screw, the circuit will be completed and the electric bill will start ringing. So, this way, the expansion or the differentiation in expansion in solids, this property is used to build this automatic fire alarm device. Students, liquids also expand on heating, and liquids experience cubical expansion, means they increase or they expand in their volume. But different liquids have different rates of expansion for the same rise in temperature. Students, in this activity, this different expansion of different liquids for the same rise in temperature that is shown here. Here, 4 glass fluxes are taken, and the 4 glass fluxes are filled with the same volume of different liquids. Flux A is filled with water, flux B is filled with ether, flux C is filled with benzene, whereas flux D is filled with alcohol. And students, now these glass fluxes are kept in a glass trough, and this glass trough is filled with hot water. And as the glass trough is filled with hot water, so the liquids inside the four fluxes will be heated. And when the liquids inside the fluxes will be heated, they will expand. And here you see, students, it is shown that the liquid ether, the level of the liquid ether has risen to the maximum level, and it is following by the liquid benzene. The level of the benzene has risen to the second highest level, and it is followed by the alcohol. But water, the rise in the level of water is the minimum. Though all the liquids are subjected to the same amount of heat. So, in conclusion, it is clearly shown that different liquids expand differently even when they are subjected to the same amount of heat. Students, for this reason, kettles and saucepans are not filled up to the brim, because when they will be heated, they would overflow. And also considerable space is left in medicine bottles to allow expansion, to allow space for expansion when they are sent to different climatic area. Students, here an important point is given here, that is anomalous expansion of water. Students, we know that most substances expand on heating and contract on cooling. But water behaves differently. Means when water is cooled below 4 degrees Celsius, then it expands. Means when hot water is cooled and it contracts, it keeps on contracting. But when the temperature goes down or reaches at 4 degrees Celsius, then if the water is cooled further, it starts expanding. And hence, as it starts expanding below 4 degrees Celsius, the density of the water starts decreasing. And for this reason, the maximum density of water is at 4 degrees Celsius. This strange behavior of water is known as anomalous expansion of water. So students, when water freezes to ice, its density is less than the water from which it is formed. And for this reason, ice floats on water. And as a result, the waters in lakes and ponds freeze slowly from the surface. And it helps the aquatic life to live under the snow or under the ice. And for this same reason, water pipes sometimes burst during winter, and ice cubes in ice trays bulge out at the top free surface. Next, students, the thermal expansion of gases. This is the last point of this chapter, the thermal expansion of gases. Students, we know that gases too experience cubical expansion on heating. And gases expand much more than solids and liquids. Students, in this activity, the thermal expansion in gases is shown here. In this activity, a balloon is tied up around the neck of an empty can, and the empty can is heated for some time. After being heated, it is observed that the balloon is growing bigger in size. As the air inside the empty can increased or expanded in volume on being heated, it is giving pressure on the walls of the balloon. And for this reason, the balloon is filling up or it is growing bigger in size. So, in conclusion, it is said that, or it is written, gases expands on heating. So, students, this much, this much only in your syllabus of the chapter of heat transfer. And if you have any query, you can send me the query in the comment box. I will give answer to that. Okay, students, thank you. Thank you for watching.